Hello everyone, and welcome back to a good old classic PCB overview video. As I was going through my catalog the other day, I noticed that I never really did a video going into the details of the VRM and PCB of this GTX 1080 here. And yeah, I'm doing that now because this is actually a pretty interesting PCB with a surprisingly good VRM, even though it wasn't really supposed to be, because the reason this 1080 exists as it is really just a cost-saving measure, but one that really works out in the favor of the card. So yeah, this is a quite interesting case, and that's why I'm making a video about it. And before we get started, as always, I can recommend you PCBWay. Before we continue, I'd like to thank our recurring sponsor, PCBWay. PCBWay offers professional PCB manufacturing and assembly services of all shapes and sizes, whatever you need for your project. You can quickly get a quote by just telling them some basic information about what you need, and if you like what you're seeing, you can upload your design files and go straight ahead to payment, fabrication, and then shipment. And even if you don't need a PCB-specific project, you can still find some very good options here, because PCBWay also offers CNC machining, sheet metal fabrication, 3D printing, and even injection molding. If any of this sounded interesting to you, then please go ahead and give PCBWay a try. So yes, here we have the GTX 1080 that I did my very sketchy, probably you shouldn't do it, memory module reflow a while back. Surprisingly enough, the card still works. It seems like I actually got lucky and it really just had a cracked solder ball. I still don't recommend that repair to anyone, but well, the card still works for now. But let's not talk about memory repair here, let's talk about the power delivery. So this card right here is an 8-phase V-Core VRM and a 2-phase memory VRM. So that's pretty much already the higher end of VRM phases you can have on a GTX 1080 without using doublers, because pretty much the one and only PWM controller used on GTX 1080s is this right here, the UP9511. This is used on pretty much any higher end 10 series card, 1070 and up. There is a cut down variant with I think 6 or 4 phases that you can sometimes find on 1060s, and then there's also some I think a 4-phase on semiconductor controller that you can find on some 1060s. But pretty much all the higher end cards, GP104, GP102 based, they are going to use a UP9511, which is a fine controller. It is a fairly basic and cheap controller, but it is an 8-phase controller and it does what controllers do. It just doesn't do anything fancy like I2C control. So there is the UP9512, which is basically this controller, but it has some I2C, and then of course there's the high-end solution, which is the MP2888 and its derivatives that you can find on some 20 series and 30 and 40 series. But for the 10 series, it's pretty much only the UP9511. So if you want to go over 8 phases, you need doublers, and that has a fair share of trade-offs with it. So really, you're looking at 8-phase VRMs for high-end Pascal, which is fine. There's some 1080 Ti's that use doublers to go to 12 phases, but for 1080s, 8 phases is quite typical of a high-end card, and it's perfectly fine. Honestly, this didn't even need to be an 8-phase. This could have been a 6, maybe even a 5. If you look at the 1070s I have, those are 5-phase VRMs, very similar VRMs to this one per phase, and they're perfectly fine. Now a 1080 does draw a bit more power, so maybe this should have been a 6-phase, but we have 8. So that is quite good. And one of the main reasons why this is probably an 8-phase, and just why this PCB as a whole exists, is actually a different card from a completely different generation, one that I happen to also own, and that is the GTX 980 Ti Omega Edition. And as you can see, those cards look very similar, especially when it comes to the V-Core VRM, because yes, that is essentially the same V-Core VRM. The only difference is that the 980 Ti uses a different controller, and the layout of the output filtering is slightly different. Everything else is literally the same. So yeah, this VRM was first designed for this 980 Ti right here, and on this 980 Ti it is... I mean, it's alright. This card has a 450 watt limit, that's quite a lot, and it does handle it, but the VRM gets very, very hot. It is fairly sketchy. I think this VRM, it cannot be pushed any higher than it already is out of the box, which is why I've never really tried any, fancy overclocking with this card, because I have a feeling I will just blow up the VRM. So yeah, on this 980 Ti, that VRM it's better than reference, but there's far better options, like the Strix. There's a 12-phase gigabyte card, the Hall of Fame, the classified. This is not really a very high-end 980 Ti. This is somewhere in the middle region where, it's better. You can definitely overclock this, but it's not really something you would want to extreme overclock, because I have a feeling it's going to blow up on you. But Zotac had this design, and then when the 10 series came around and Zotac was tasked with designing PCBs for the newer 10 series cards, seemingly they went, you know what, 10 series is more power efficient, and we already have this VRM design which is good enough, let's just copy paste it onto the 10 series and save ourselves a bunch of time and effort. And that's essentially what they've done. They have adapted the VRM to run with the UP9511. They have actually upgraded the memory VRM somewhat, we'll get into that later. And there have been some slight layout changes since, of course, the 10 series is a different generation of graphics cards. Specifically, the GP104 has a completely different memory setup than the GM200. But VRM-wise, apart from the controller, this is the same thing. It uses the same MOSFETs, the same capacitors, the same inductors, same layout, same heatsink even. So yeah, basically same VRM. So what is used in this VRM? Well, in terms of the MOSFETs, this is using UPI semiconductor MOSFETs, just like the controllers. And specifically, the high-side MOSFET is the M3054M, and the low-side MOSFETs are the M3058Ms. Now, the M3058Ms, they are okay. Again, these are okay MOSFETs. They are not particularly high-end though. They have a continuous drain current rating of 89 amps, which is quite a lot at 100 degrees case temperature, but their rating drops off dramatically if you go over that, because their 25 degree ambient rating, which is the MOSFET is in a 25 degree ambient without any cooling on it, that's only 21 amps. So essentially what that tells us, once the MOSFET case temperature goes over 100, your current it just vanishes, it goes away. So you do want to keep these MOSFETs at or below 100 degrees case temperature. Go over that and yeah, draw enough power and it's gonna blow up, which is why I'm so sketched out with that 980 Ti, because the VRM gets so very hot on it. Not on this 1080 though. This 1080 doesn't draw enough power to make this VRM run hot. Maybe a little bit warm, but it's gonna be fine. You're not going to get these MOSFETs to 100 degrees without turning off the fans, and you'll have larger problems by then. So, while on the 980 Ti this VRM is a bit sketchy, on this 1080, this is quite honestly overkill. Yeah, the MOSFETs are not super high-end, but given that this card doesn't draw enough power to really make them run super hot, you are going to get that pretty high current rating. And the fact that you have two low sides, I mean, this is basically standard when you have discrete MOSFET VRMs, especially VCore VRMs, you usually get two low sides, which means that the rather meh RDS on of the MOSFETs also gets halved, because they have a rating of 2.4 milliohms of RDS on. Two of these in parallel means it gets halved to 1.2 milliohms of RDS on, which is, yeah, 1.2 milliohms, it's decent. It's not what I would describe as very good. I would maybe want 0.8 to 1 milliohm, but 1.2, it's okay. But you'll feel the effect of the higher resistance once you push a lot of power through it. Again, a problem with the 980 Ti. On this, I think it's fine. It's just fine. There's not really anything wrong with the MOSFET components. It is a very Zotac decision to go with, yeah, like, we'll use some kind of meh MOSFET, but we'll just, have enough phases of them that it kind of doesn't matter that the MOSFETs are not that great, we're just gonna win by numbers. That is the typical, Zotac approach. Because, again, like, this doesn't have to be an 8-phase, and because it is, you just kind of have enough MOSFETs that it is going to be power efficient simply by, you have enough MOSFETs and your current gets split enough times that the inefficiency of the MOSFETs doesn't really show that much. So, yeah, it's fine. It's a Zotac VRM, so this is kind of about the best you can wish for. There are actually cards where they do the same thing, and where it doesn't work, they actually have a 1080 Ti where they go super crazy and they basically double up this VRM and they go with what looks like a 16-phase. I mean, there's no 16-phase controller from that time, so it's either doubled or just running as a massive, really, really fat 8-phase. But yeah, that card has enough components to make a 16-phase, and somehow it's just as power efficient as a reference card, which I think is a 7-phase? So yeah, the MOSFETs they use were very trash. You have more than twice the phases and somehow your power efficiency is the same. So, yeah. Yeah, back to this card. The VRM components are fine. Like, this is fine. You're not gonna max this out. I think this VRM is more than enough to extreme overclock this card, so go out and volt mod it. Cap modding probably doesn't do that much to it, because the output filter on this, we'll get into that, is already kinda good. But yeah, you could mod this and extreme overclock it, and I don't think the VRM will hold you back. So that is really the main important thing. Because this is essentially a 980 Ti VRM on a 1080, the VRM is massive overkill. So, speaking of the capacitor configuration, this is another thing that Zotac really likes to do, is they like to use capacitors with very high capacity ratings. So on the input side you get 330 microfarads, and on the output side you get 1200 microfarads. Typically you would see something like 270, or maybe even 150 on the input, and then usually 820 on the output. So yeah, this is a decent bump in capacity, and yeah, it's something that Zotac likes to do. It's something that works, but probably not the way you would expect, because this has basically no advantage over what everyone else does. Higher capacity capacitors, unless you want to spend significantly more money on them, they are going to have trade-offs. Specifically, if you want higher capacitance, they are going to have worse electrical characteristics. So your equivalent series inductance, your equivalent series resistance is going to go up, which is going to decrease the impact that the capacitor has. Essentially, it makes the capacitance less efficient, so to say. So you have these higher capacity capacitors, but I doubt that Zotac spent a lot of money on these. They probably spent about the same as everyone else, because they gotta make money at the end of the day. So I don't think that these capacitors have very good electrical characteristics, which means that, yeah, they have higher capacities, but it sort of just kind of cancels out. And at the end of the day, I think these capacitors act essentially the same as what you see on every other card. Since if it was better, then I would expect more manufacturers to do this, but so far Zotac is the only manufacturer that consistently does this. Sometimes you see it on Galaxy Hall of Fame cards, but there it's really just for the reason because why not? And actually those might actually go for the really expensive capacitors that actually have the good electrical characteristics and the high capacitance, since it's a Hall of Fame card, it's not this. So yeah, it's always interesting to see Zotac with these high capacity capacitors. They do it on pretty much every card they make, and I mean, I guess it's nice that it's there. I don't think it really does anything. It's just kind of noteworthy because you don't really see capacities as high as these usually. Now, if you look at the rest of this section, it kind of looks a little sad because you have these CAN types, which you pretty much have every time, and then you have just a few multi-layer ceramics, and that kind of makes the VRM look like it's not very good. However, there is actually quite a fair amount of extra filtering on the back. So we have a few more multi-layer ceramics. We have these two SMD polymer capacitors, which are 470 microfarads, and we have this thing that says power boost on it. Now this might look like a proglyzer, but it isn't. I assumed it was one for a while, but I found an image on the internet of someone removing this metal case from it and revealing that this is just more SMD polymer capacitors. If I remember correctly, it is 6 of them. It might be 8, but I think it's 6. And the way this is done is there's just a little daughter board which has the capacitors on them, and then that daughter board has this metal case on it. So yeah, it's a bit of a complicated, weird way of attaching more capacitance, but yes, essentially the backside of this PCB has 8 total SMD polymer capacitors and a couple extra multi-layer ceramics, which if you add that together with the other multi-layer ceramics you see on the front here and the CAN types, that's actually a pretty decent output filter. It's not the best output filter ever, but remember, this is a 1080. This is a sub 300 watt card, and for that I think it's fine. If you look at, well, a GTX 680 is maybe not the best example, that is a sub 200 watt card, but like a GTX 980, for example, you would see same or worse output filters than this on average. And also looking at the 1070s, I think those straight up don't have any of the SMD polymers, and the rest is basically the same. And having SMD polymers, it tends to really help a VRM. They are this kind of nice middle ground where it actually adds a decent amount of capacitance to your output filtering, but those capacitors also have pretty good electrical characteristics, so they are kind of they're a nice in-between tier between CAN types and multi-layer ceramics. So yeah, I like the output filter on this as well. I also like the output filter on the memory VRM, because the memory VRM output filter is actually not using any CAN types, probably because of the placement of the memory VRM, which I also actually like. This makes the VRM very close to the memory chips. There are some other cards that have their memory VRM like all the way back here, and I mean that works. Memory chips don't draw that much power, but just the distance. You have a lot of inductance in your power plane, and that just messes with the voltage regulation. There's actually some EVGA classified cards which usually have the memory VRM all the way back, like here. You see this massive array of capacitors close to the memory chips in about this area, where they try to counteract that, where like instead of having most of the capacitance at the VRM, they have it like in this area close to the memory chips, and then the power just goes to the capacitors first and then onto the memory chips. But you know, if you place your memory VRM like here, then you don't have that problem. So I like that this is close to the memory chips and also kind of in the middle of them. Sometimes you see the memory VRM like down here, but then the power has to like make this shade like go this way, where instead here it like splits, which decreases the effective distance from the VRM to the chip here. So yeah, basically you get better voltage regulation that way. So I like that the VRM is placed like here. And I also like the capacitor selection because we have 3 capacitors on the front here, and we have a further 3 on the back, which should also be the same for the 980 Ti. It has a slightly different layout, 2 on the front and then 4 on the back, but very similar idea with the 980 Ti. One thing that I will say about the memory VRM that I don't like, specifically on the 980 Ti, is those inductors are known for burning out. And also, I can't fail but notice that this only has 1 low side. That has 2 low sides per phase. Which is kind of weird considering that this has the more power-hungry memory setup. So yeah, this memory VRM on the 980 Ti is not really the best. It is probably fine because there is some decent cooling for the memory VRM, which should prevent the problem that I'm gonna talk about right now. But there are some 980 Ti and 780 Ti cards that have a problem, that have memory VRMs that look basically exactly like this, and their inductors burn out, and sometimes also their MOSFETs fail. Because typically those cards don't have very good memory VRM cooling, and then these components run hot, and because these are just a little bit too close to being maxed out, you can have these components fail over time, which is especially a problem with reference PCB 980 Ti's and 780 Ti's. And yeah, this is essentially just a copy-paste of the reference 980 Ti memory VRM, which is slightly problematic. Now, I don't think this specific card has a problem because, again, it has decent cooling for the memory VRM, but on cards that don't have that, this sort of VRM tends to fail a lot. Which apparently Zotac seems to be aware of because they have upgraded the inductors and added a second low-side MOSFET for the 1080. The only problem really being that, this is a 1080. It doesn't need that. There are 1070s which use only one phase for their memory VRM, and admittedly 1070s don't have GDDR5X, but it is the same core and the same memory bus, and I don't think GDDR5X uses 2 times the power, because it doesn't. So, yeah, it's nice to see they upgraded the memory VRM, it's just like, this is not the card that would need it. But yeah, the output filtering on this I like. 6 capacitors, SMD polymer capacitors at that, is a nice amount of output filtering for the memory, especially on a smaller bus like this, the 256-bit bus. So yeah, I expect memory voltage regulation to be quite good. Since these are Micron chips, I would also expect these to lock quite a bit better if you just overvolt the memory. I haven't tried that yet, and still it has this sketchy memory module on it that might just randomly fail on me. But yeah, I think this would be a decent candidate for just modding. And I might actually do that. Yeah, like the main reason why I haven't modded this yet is just because I have the feeling the moment I mod it, this memory module is gonna die and the card will be just unrepairable. Because I would have to source replacement GDDR5X and I don't have a donator. I actually have a dead 1080 Ti, but I think pretty much all the modules on it are just dead. So, yeah. Anyway, is there anything else that I've missed? I guess we could talk about the heat sinking a little bit, because I have mentioned it. So, the vCore VRM has its own dedicated heatsink on this card, which is... yeah, it's not a very big heatsink, but it's nice that it's there. And I like cards that have these dedicated heatsinks because it makes disassembling the card and water cooling the card a lot easier, because, well, the VRM still has its cooling. Now, the memory VRM cooling is integrated into the main heatsink, but that's small enough, you can just thermo tape a Raspberry Pi heatsink on that and then it's done. Or just have a high RPM fan on it, then it's probably fine without a heatsink as well, except maybe on that 980 Ti. But yeah, so the VRM heatsink on this, it's fine for the 1080. For the 980 Ti, maybe I would have liked something a little bit more substantial. But yeah, it does also kind of help the main heatsink. So this is from the 1080. The main heatsink has rather thick fins, which means that they do leave a decent amount of space between the fins, so you get a nice amount of airflow through the fin stack actually onto the VRM heatsink, which means that even though the VRM heatsink it's a little bit smaller, it's gonna be quite effective with this decent amount of airflow. Oh, and by the way, yeah, I did hot glue a shroud onto this. I got the heatsink, like literally just the heatsink, I didn't get the shroud, so I took the shroud from a dead GTX 580 Lightning and hot glued it on, which works surprisingly well. This runs very cold and very silent, so it is actually a pretty good heatsink. But yeah, yeah, in general, it's a decent heatsink, and this is not even the highest end version of the card that they ship. Like, this is the 2-fan variant, and then there is a version of the card that I think ships just with the same heatsink as the 980 Ti here, which is this much larger 3-fan heatsink. As you can see, very similar idea. Same idea with the fins as well. Just, yeah, it's longer, thicker, and it has 3 fans instead of 2. And honestly, I really like this heatsink. This is probably one of my favorite heatsink designs because it's just... there's nothing over the top about it. Like, there's no dumb RGB anywhere, no stylistic things. It's just... it's a decent heatsink. This one's also fairly silent and works fairly well, especially considering that the 980 Ti does have that 450 watt power limit. So, yeah, I like this heatsink. This is actually a pretty nicely designed, well-functioning heatsink, which again is quite untypical. I say that about something made by Zotac. Like, Zotac's kind of known for making like these cheaper, lower-end cards. But every now and then they make something like this, which I guess the 1080 was more of a happy little accident than on purpose, but pretty good design. This is honestly one of the better 1080s. I would recommend this for messing around with it. This is probably one of the better cards you can get for modding. Like, yeah, I don't think I would say that the Strix is much better than this. The Strix is probably more power efficient because it does use proper power stages, but the Strix is also an 8-phase, I think. Yeah, I think the yeah, the 1080 Strix is an 8-phase. The 1080 Ti Strix, I think that's a 10-phase. Because I think that might be one of the few cards that use a different PWM controller, but I'm not entirely sure about that actually. But yeah, the 1080 Strix is also an 8-phase. I think it uses IR3555s, so that's 60 amp power stages, which means that as long as you keep this VRM cool, this can actually handle more power. But the Strix is gonna be more power efficient, so it's not quite as a massive difference as you think, because this VRM will heat up faster. But yeah, like in terms of general impression from this PCB, I like this. This is a good 1080. It's a 1080 I don't see a lot. Honestly, I didn't even know this PCB existed until I got this 1080. Like, I knew about the 980 Ti existing, but I didn't know that they basically reused the VRM on a 1080 as well, and because it is essentially a 980 Ti VRM on a 1080, it's a very good design, actually. This is kind of similar to when EVGA reused the GTX 580 classified VRM on the GTX 680 classified, which is a similar jump downwards in power consumption from the 580 to the 680. So, yeah, this is one of those cases where the manufacturer, saving some money, actually worked out to produce a very, very good design. Because, yeah, using the previous generation VRM on a 1080, that's just because of the power efficiency of Pascal, just leads to a very, very solid PCB. And I think with that, I have said everything that I wanted to say. And until next time, goodbye.